Section 4.3 is applications of systems of linear equations. All right, so we want to learn how to solve systems of equations in 3 or more unknowns that can actually appear in the real world, and I've already given an introduction for that. Okay, so example 1. Example 1. The Arctic Juice Company makes 3 juice blends: pine orange, using 2 quarts of pineapple juice and 2 quarts of orange juice per gallon; pine kiwi, using 3 quarts of pineapple juice and 1 quart of kiwi juice per gallon; and orange kiwi, using 3 quarts of orange juice and 1 quart of kiwi juice per gallon. Okay, all right, so we have pine kiwi using 3 quarts of pineapple juice and 1 quart of kiwi juice per gallon, and orange kiwi using 3 quarts of orange juice and 1 quart of kiwi juice per gallon. Each day, the company has 800 quarts of pineapple juice, 650 quarts of orange juice, and 350 quarts of kiwi juice available. Set up the system of linear equations needed to find out how many gallons of each blend should it make each day if it wants to use up all of the supplies. So, the first thing, I know this is a lot, but to break it down, what's unknown here? What don't we know? Yes?
The amount of gallons of each kind of juice.
Very good. So we don't know the amount, or know the amounts or the gallons of each number of each juice, right? So that's our unknown. So now let's put some variables with that. Okay? So I'm going to move this up. So let X be equal to the number of gallons of, why do I do that? Pine orange made each day. Let Y be equal to the number of gallons of pine kiwi made each day. And let Z be equal to the number of gallons of orange kiwi made each day. Okay, so those are our unknowns. Do we have any more? No, we don't. Good, we do not. Okay, so now what we're going to do is we're going to take this information and we're going to use it on the next page. So you'll need to keep referring back to the actual information there for the problem. Now what we're going to do is we're going to put a table together with all of the information given. Okay, so the first thing first, we need to make sure we label our table and what to fill it in with. So let's do that. So we had our pine orange. Is it okay if I just use the variables? Okay, so we had our pine orange, which was X. We then had our pine kiwi, which was just Y. Then we had our orange kiwi, which was Z. And then, ignore the word table over there. And then we had the total available. So what we have to figure out whenever we're figuring out our rows, remember the X, Y, and Z are blends, right? So what should the rows be made up of? Yes.
The different kinds of juices.
The different kinds of juices. Excellent. The different kinds of juices. So we're going to have pineapple juice. We're going to have orange juice. And then we're going to have kiwi juice. All right? So, for pineapple juice, when we're making the pine orange, how many quarts do we need? So right now we're going to fill in this spot. Well, why did I draw this extra line here? Let's erase this. We only need one, right? Okay. So for our pine orange blend, how much pineapple juice do we need? 2. Good. For our pine kiwi, how much pineapple juice? How much? 3. Good. What is Z? 0. Good. Total available for pineapple juices? Talk loud. What's the total available for pineapple juice? 800. Good. 800. Okay, so that's what we have. For orange juice, what's that row? You tell me. What's the row going across? Talk loud. 203. Excellent. Because for orange juice, for the pine orange, you need 2 quarts. For the pine kiwi, which is Y, you need 0. And then for the orange kiwi, you need 3 quarts of orange juice. Okay? And then what's your total available of orange juice? 650. Good. Tell me the last row for kiwi juice. Not everybody at once. So we read our problem. It says for pine orange, using 2 quarts of pineapple juice and 2 quarts of orange juice per gallon. Pine kiwi, using 3 quarts. Go ahead. 0, 1, 1. Very good. 0, 1, 1. Okay? Because you don't need any kiwi juice when it comes to your pine orange. For your pine kiwi, you need 1 quart of kiwi juice, and then for your orange kiwi, you need 1 quart of kiwi juice. Good. What's your total? 350. So now what we want to do is we want to take this table and the information that we've gathered and translate that into a system of linear equations. So let's do that. So the first row means you have 2x plus 3y plus 0z equals 800. So that translates as 2x plus 3y, that would be 0z, so we don't have to write anything, equals 800. Would you like to write 0z? Okay. Then, what's your next equation?
2x plus 3z equals 650.
Good. And what is your last one? Y plus z equals 350. Good. Okay? Then you can put that into a matrix form and then you could row reduce it. Okay? Then you could row reduce it. Whenever you do that, so you would put this into this form. So you would have 2, 3, 0, 800. You would write the augmented matrix. Then you would have 2, 0, 3, 650. Then you would have 0, 1, 1, 350. And you would go through and row reduce it and solve it. Okay? Yes, there's a question. So after row reduction here, so after row reduction, you would find that the solution is XYZ equals 100, 200, 150. So Arctic Juice Company should make 100 gallons of pine orange, 200 gallons of pine kiwi, and 150 gallons of orange kiwi each day. All right, so this is a way that you can check your solutions. You can go to the website www. Let me type it in, www.wainermath.com. And whenever you go there, you go to the website, and then you click Online Utilities here. Once you click Online Utilities, well, let me not write on it. You click Online Utilities, you scroll down until you see the Pivot and Gauss-Jordan tool. You can click that. So you're going to click this. And then what we're going to do, once it loads, wow, would it come up? Let's pause. Okay, so what we actually want to make sure we click here is we want to make sure that we click the Pivot and Gauss-Jordan tool, the first one. You click that one, and it takes you to this sheet, okay, this Excel sheet. What you will do at this point, you'll enter the values from your table in these entries. So you would enter a 2 here. Then you would enter 3, 0, 800. And then you would go to your second row, and you would enter 2, 0, 3, and 650. And then you go into the third one, and what would you enter? 0, 1, 1, 350. Good. And then you would go up to the top where it says Reduce Completely. Click Reduce Completely. And whenever you hit Reduce Completely, you get the identity matrix right here. So you get ones along the main diagonal. You interpret this as, let me see if I can zoom in. Is that better? Okay, so you would read this as X equals 100, Y equals 200, and Z equals 150. Okay, so this is a way that you can check yourselves whenever you're working through your homework as well. Way that you can actually go through and check yourself. Remember, you do need to actually know the steps for row reducing, okay? But this is just a way to help, okay? All right, so let's look at another example. Let's talk about resource allocation. Let's talk about resource allocation. So, you own a hamburger franchise and are planning to shut down operations for the day, but you are left with 13 buns, 19 defrosted beef patties, and 15 open cheese slices. Rather than throwing them out, you decide to use them to make burgers you will sell at a discount. Plain burgers each require one beef patty and one bun. Double cheeseburgers each require two beef patties, one bun, and two slices of cheese, while regular cheeseburgers each require one beef patty, one bun, and one slice of cheese. How many of each should you make? How many of each should you make? What are our unknowns? What are our unknowns? Yes,
How many of each burger?
that's absolutely good. So those are the variables that we need to introduce. So you said we don't know how many of each burger we need, so that's what we need to label it as. So let X be equal to the number. Are you okay with using that for number? Okay, the number of plain burgers. Let Y be equal to the number of double cheeseburgers. And let Z be equal to the number of regular cheeseburgers. Now, it's okay if you don't use the same variables or if you have them in a different order. It's okay as long as you're consistent throughout the entire problem. Okay? So, now we set up our table. We set up our table. So, we'll have our plain burgers. Do you want me to write the word or is the variable just okay? The variable. So, X represents the plain burgers. Y represents the double cheese. Z represents the regular cheese. And then in the last column, what should we have? The total. Good. Okay. Total available. But then, to make up X, Y, and Z, we need patties, we need buns, and we need cheese. So that will make up our row. So we have the beef patties, we have the buns, and we have the cheese slices. Okay? What is the first row?
1, 2, 1.
Talk loud, please.
1, 2, 1.
1, 2, 1. Good. What's the last one? 19. Very good. For buns, what's the row for buns? Now's the time, if you haven't answered, to answer. Go ahead. 1, 1, 1, and good. The last row. 0, 2, 1, and 15. Good. Very good. Okay. So now what we're going to do, we're going to set that up in a matrix. You can choose to write down the equations if you like, but all you're going to do is take that anyway, take those coefficients and form your augmented matrix so you can row reduce, so you don't have to necessarily write that step. Okay? So I'm going to make this a little bit smaller so we can write. Can you still see that? Okay, so let's set up our matrix. So our first row, we're just going to take the entries from our table, put them right inside of the matrix. So you have your first row is 1, 2, 1, 19. Second row, your second row is 1, 1, 1, 13. And your third row is 0, 2, 1, and 15. And this is just a random mark right there, okay? So now what we're going to do is we're going to row reduce. So our goal is to get ones along the main diagonal, 0 here, 0 here, 0 here, 0 there, and there. Okay, that's our goal. So now let's do it. How can we make this a 0?
Okay, row one,
From?
row two.
Very good. So we say row 2 minus row 1 to get a new row 2. That will give us, row 1 is going to stay the same. So we'll have 1, 2, 1, 19. Then we're going to have row 2 is changing. So we said 1 minus 1, that gives us 0. Good. Then we're going to have 1 minus 2, that gives us 1 minus 2 gives us negative 1. Good. 1 minus 1 gives us 0. And 13 minus 19 gives us negative 6. Be careful with your signs. Negative 6. Good. Okay. Then row 3 did not change, so we write down 0, 2, 1, and 15. Okay. Now, we created a 0 here successfully. Now what we want to do is we want to make this 2 a 0, and we want to make this 2 a 0. We can leave the negative 1 as is, or you can go ahead and multiply row, you could multiply row 2 by negative 1, or you can just leave the negative 1 and use that, okay? So I'll use it, and we'll create zeros where the 2's are. So creating a 0 here and here. So to do that, I'll start you out. We want to change row 1. So we're going to say row 1 plus 2 times row 2 to give us a new row 1. So now we're using this negative 1 as our pivot. Initially we used this 1 as our pivot. Okay, so now what we're going to do, we're going to say row 1 plus 2 row 2 to get a new row 1. Okay, so in this step, row 2 will not change. We're going to put an operation to change row 3 as well, but not yet. So row 2, I'll just write down 0, negative 1, 0, and negative 6. Okay, now row 1, we're doing row 1 plus 2 row 2 using this matrix. So 1 plus 2 times 0 is 1. Good. 2 plus 2 times negative 1 is what? 0. Good. Then you have 1 plus 2 times 0 is 1. Good. And then the last entry, what are you going to get? Very good. You're going to get 7. You're going to get 7 there because you're doing 19 plus 2 times negative 6. So that's 19 minus 12 gives you 7. Okay? Excellent. Tell me how we can create a 0 here. What's the operation? Talk loud, please. Row 3 plus 2 row 2 to get a new row 3. Very good. Would you like a minute? Okay, go ahead and take it. What do we get for row 3 using this operation?
0, 1, 3.
Very good. 0, 0, 1, 3. Excellent. Okay, now what we need to do is we need to create a 0 here. What's going to be our pivot? Yes?
We use the one on row 3.
Yes, absolutely. Use the 1 in row 3. That's our pivot now. Now, what's the operation that's going to get that to be a 0? So I'll draw an arrow there. Go ahead.
Row 1 minus row 3.
Good. Very good. Row 1 minus row 3 to get a new row 1. Want a minute to get it? Okay, go for it. All right, what did you get for row 1?
0, 4.
Say it again.
0, 1, 0, 0, 4.
Good. Very good. Row 2 and 3 didn't change, so that's 0, -1, 0, -6, 0, 0, 1, and 3. Now what do we need to do? Go ahead.
Multiply row 2 by -1.
Very good. So -1 times row 2 to get a new row 2. And then our final matrix is going to be 1, 0, 0, 4, 0, 1, 0, 6, 0, 0, 1, 3. So what can we say? Yes?
X, comma, Y, comma, 3 equals 4, comma, 6, comma, 3.
Equals 4, comma, 6, 3. Very good. Very good. Okay, so you need how many plain burgers? 4 plain burgers, 6 double cheeseburgers, and 3 regular cheeseburgers. Okay, what questions do you have? So you actually can apply what you're learning, right? Because these are examples that you use in real life. Okay? Okay, so the fancy French perfume company recently had its secret formula divulged. It turned out that it was using as the 3 ingredients rose oil, oil of fermented prunes, that doesn't sound like it's pleasant smelling, and alcohol. Okay? Moreover, each 22-ounce econo-sized bottle contained 4 more ounces of alcohol than oil of fermented prunes, while the amount of alcohol was equal to the combined volume of the other 2 ingredients. How much of each ingredient did the company use in an econo-sized bottle? I see some facial expressions like, what in the world? Let's take our time, go through it. What don't we know? Yes.
Well, how much of each ingredient?
How much of each ingredient? Excellent. So our unknowns, let's write those down and label those. So our unknowns are the, let's call X, the number of ounces of rose oil. Let's call Y the number of ounces of fermented prune oil. And then Z is going to be the number of ounces of alcohol. Okay, so those are our unknowns. Now, we have to figure out how to come up with our equations here. It says, moreover, each 22-ounce econo-sized bottle contains all of this, okay? So, let's just read it. Moreover, each 22-ounce econo-sized bottle contains 4 more ounces of alcohol than oil of fermented prunes, while the amount of alcohol was equal to the combined volume of the other 2 ingredients. So it seems like here we can take 2 equations, right? But then the question is, what is the other equation? The other equation would just be the total, right? Figuring out what the total would be. And to figure out the total amount in the bottle, that means you just need to add X, Y, and Z, right? Are you with me?
Yeah.
Okay, so that's going to give us one equation. So we have a few things to factor in here. Make this smaller. We're gonna need the room. Can you still read that? Okay. So we have the total amount in a bottle is 22 ounces. So from that, we can conclude, I'll write our equations in green. So we have x plus y plus z equals 22. It's an equals, okay? So that's one factor. Another thing we can say is that each bottle contained 4 more ounces of alcohol than oil of fermented prunes. So what this means is, this means that, hold on. So here, this equation, or that sentence, translates as Z is equal to Y plus 4. Z is equal to Y plus 4. Okay? So another factor we have is that the amount of alcohol was equal to the combined volume of the other two ingredients. What does that translate as? Yes. Z is equal to what? X plus Y. Good. Z is equal to X plus Y. Now, it's going to benefit us to take a look at these equations, this one, and this one, and figure out how we're going to arrange it. Notice that the total is given by X plus Y plus Z equals 22, so we have our variables on one side. And thinking in terms of an augmented matrix, we always had our variables on one side and our constant terms on the other side of the equation. Does that make sense? Hello?
Yes.
Okay, so let's rewrite the equations here and here in that same form so we can just set up our augmented matrix using those forms. So what would this equation here be? Yes? Go ahead. You can do it. Yes?
Z minus Y plus 4.
Would it be easy to read it as Z minus Y when you're translating that into your matrix? Or how do you want it?
Negative Y.
There you go. Very good. Negative Y plus Z equals 4. Very good. What's the last one here? Say it again. That's what we have. We have Z is equal to X plus Y. Yes?
X plus Y minus Z is 0.
X plus Y minus Z. Yes. X plus, right? X plus Y minus Z equals 0. Okay? So those are our equations. Now we can take the coefficients of those equations and the constant term and create our augmented matrix. So let's do that. The first row is going to be what? Based on our first equation.
1, 1, 1, 22.
Good. 1, 1, 1, 22. What's the second row?
0, -1, 1, 4.
Good. And what's the third row?
1, 1, -1, 0.
Good. Good. And now we want to row reduce. Now we want to row reduce. All right, so we want to create a 0 here. We use the top one as our pivot. How do we do that? What's the operation is what I'm asking.
minus R1.
I can't hear you.
R3 minus R1.
Good. R3 minus R1 to get a new R3. Row 1 and 2 stay the same. So it's 1, 1, 1, 22, 0, -1, 1, and 4. What does row 3 become? 0, 0, -2, and -22. Very good. Very good. Look at row 3. What can you do? Multiply row 3 by -1/2. So -1/2 times row 3 to get a new row 3. What does that give us? Row 1 doesn't change and row 2 doesn't either. So that's 1, 1, 1, 22, 0, -1, 1, and 4. And what is row 3? 1, 11. Good. Okay. Now, what's our next operation? Very good. R1 plus R2 to get a new row 1. Notice that he started out initially saying row 2, but realized he wanted to change row 1, so he started out with row 1. That's a good thought process. Okay? So, what's row 1? Talk loud, please.
1, 0, 2, 26.
Good. Row 2 and 3 didn't change. So you have 0, -1, 1, 4, 0, 0, 1, 11. Now what do you want to do? What row do you want to change first?
R2 times -1.
Say it again.
R2 times -1.
Okay, so -1, R2 to get a new R2. So what does R2 become?
0, 1, -1, -4.
Okay. Now what do you want to do? Yes.
R1 minus R2, R3.
R1 minus 2 to get a new
R1.
R1. And that's going to change row 1. And what other row do you want to change? Can't hear you. What other row do you want to change? Row 2. So what would that operation be?
R2 plus
R2 plus R3 to get a new
R3.
R2. So go ahead and take a couple minutes and figure out what your rows are going to be. What do you get? Yes. You get one, you get the first row and you get the second one. Go ahead.
1004.
1004. Okay, and row 2?
0, 1, 0, 7.
Good. And then the third row didn't change, so you get 0, 0, 1, 11. Very good. So what does this mean?
X, Y, Z equals, parentheses, X, Y, Z equals, parentheses, 4, 7, 11.
Very good. And how, what does that, how would you interpret it? Good, very good.
And if, you know it's right because it equals 20.
Can't hear you?
You can kind of tell it's right because it equals 20.
That's absolutely correct. That's the connection I wanted you to make. That's the connection I wanted you to make. So you know it's correct because 4 plus 7 plus 11 is 22, which is the total number of ounces you're supposed to have. Very good. What questions do you have? All right, so for this problem, we have our dividend, or we have investing lesser known stocks. Our price for WSR was 16, dividend yield, what is in terms of percent, is 7. HCC is $56 for the price and 2% dividend yield. SNDK is $80 and 2% dividend yield. Our unknowns here are the number of shares of WSR, the number of shares of HCC, and the number of shares of SNDK. So our unknowns we're labeling as X, Y, and Z. Now we need to figure out our equations that correspond to this information, because we said you invested a total of $11,200 in shares of the 3 stocks at the given prices and expected to earn $304 in annual dividends. If you purchased a total of 250 shares, how many shares of each stock did you purchase? So we know the total investment was $11,200. Investment in WSR, that's equal to X shares at $16, so that's 16X. Investment in HCC was Y shares at $56, so that's 56Y. Investment in SNDK is Z shares at $80, so that's 80Z, which gives us the equation 16X plus 56Y plus 80Z equals 11,200. Now, you expected to earn $304 in dividends. The WSR dividend had 7% of 16X invested, which is 0.07 because we're talking about percents, times 16X. That's going to equal 1.12X. Now, for HCC dividend, what do we have? 0.02 times 56y. That gives you what? So 1.12y. Good. And then your SNDK dividend, what's that? 0.02 times 80. Z, which gives you what? 1.6 Z. So all of that to say, what is your equation? You have to talk loud, please.
1.12x plus 1.12y plus 1.6z equals 304.
Good. That's that equation. Very good. Okay? And then we have one more equation. We have not taken into account this part. If you purchased a total of 250 shares, the question is how many shares of each stock did you purchase? What does this phrase mean here? You purchased a total of 250 shares. Anybody else? Are you taking a picture of the screen?
Oh, yeah.
Okay, that's fine. Go ahead.
It would be X plus Y plus Z.
Good. Because you purchased the total, so you purchased a total of 250 shares. That corresponds to, as you said, X plus Y plus Z equals 250. Very good. Okay. So we have our 3 equations. We can set up our system. Okay. So I'm gonna zoom in, make this tiny so we can set up our system. So now we're gonna use the coefficients from the green equations to set up our augmented matrix. Okay, so our augmented matrix would be, and what I'm gonna do is rearrange it a little bit so we can have that 1 in the upper left corner, because it'll make our calculations easier. So I'm gonna put that up top. So I'm going to write 1, 1, 1, 250. Second row, I'll make 16, 56, 80, and 11,200. We have larger numbers here, but we'll figure that out. Then we had 1.12, 1.12, 1.6, and 304. All right, so now what we're going to do, I'm going to multiply row 3 by 25. So 20, right, 25, row 3 to get a new row 3. And remember, there are many ways that you can approach this problem. There are many different row reductions. You have to choose what's best for you. Okay, row 1 is not going to change. So that's going to leave us 1, 1, 1, 250. Row 2 is going to stay the same. So that's 16, 56, 80, and 11,200. And then the third row, 1.12 times 25 is what?
30.
What is it?
30.
No. 28. So you get 28, 28. And what are the other two? What's 25 times 1.6? 40. And then what's the last one? So you're doing 304 times 25? 7,600. Good. Okay. So, if you do not want to deal with large numbers like this, we then multiply row 2 and 3 by a number to simplify this. Okay? So, we can say we got 1/8 times row 2 to get a new row 2. And then 1/4 times row 3 to get a new row 3. Row 1 is not going to change. So that's 1, 1, 1, 250. Excuse me. 16 divided by 8 is 2. 56 divided by 8 is 7. 80 divided by 8 is 10. 11,200 divided by 8 gives us 1,400. What does the third row become? Seven, 7, 10, 1,900. Good. Very good. So those numbers are smaller, which makes our row reduction a lot easier at this point. Okay? So we want to create a 0 here where this 2 is and a 0 here where the 7 is. Okay? What are the row operations that allow us to do that? Yes?
We do, row 3 minus 7 times row 1.
Very good. Row 3 minus 7 times row 1 to get a new row 3.
Yeah.
What is the other operation? Yes?
Row 2 minus 2 row 1.
Very good. To get a new row 2. Very good. Would you like a minute?
Sure.
Okay. Okay, so row 1 doesn't change, right? We're using that as our pivot. So and just to be consistent, this is our pivot. So go ahead, row 1 is 1, 1, 1, 250. What's row 2? 0, 5 what? Everybody agree? So row 2, yes, that should be 8. So just to check, you would do row 2, which is 10, minus 2 times 1. So 10 minus 2 would give you 8 here. So that's the only correction. This should be 5, 8, 900. Good. What's the third row? 0, 0, 3, 150. Good. Now, what can you do to row 3? Yes?
Multiply row 3 by 1/3.
Can't hear you?
Multiply row 3 by 1/3.
Yes. So you have 1/3 times row 3 to get a new row 3. Good. So row 1 and 2, rows 1 and 2 stay the same. 1, 1, 1, 250, 0, 5, 8, 900, and then 0, 0, 1, and what? 50. Good. Okay. So this is looking good. So what can we do to make this one a 0 here? So now our pivot is going to be this 5. So how do we use it? Yeah. Talk loud, please. No. You can. So let me, so you said you can multiply this row by 1/5. If you do, you're going to create fractions. Do you want to work with fractions along the way? Okay, so if you do not want to work with fractions along the way, then you'll just want to leave this as a 5 and make this a 0. Otherwise, you will create fractions in row 2 that you will have to use. Yes?
5R1 minus R2.
5R1 minus R2. 5R1, that's a 5, minus R2 to get a new R1. Very good. And just to be clear, multiplying by row 2 by 1/5, that's a legit step. You can do it. But if you want to avoid fractions, you don't want to do that. Okay? So, row 1, you want a minute? I'll give you, okay? So, what does row 1 become? You want it? Go for it. Just tell me what you get. The same 4 people have been talking all day. Nope, same 5. With a few people every now and then. What do you get? You're doing 5 times row 1 minus row 2. 5 times 1 minus 0 is what? 5. 5 times 1 minus 5 is? 5 times 1 minus 8 is? -3. 5 times 250 minus 900 is? -650. Okay? Does everyone agree? Okay?
350.
So this shouldn't be -650. That should be -350, right?
Yeah, it's
Positive,
positive.
yeah.
It should also be positive, right? Right, because to figure that one out, you have 5 times 250 minus 900. And 5 times 250 is 1250 minus 900 gives you 350, right? Okay? The second row didn't change. So we have 0, 5, 8, 900. Then we have 0, 0, 1, 50. Okay? And then what we're going to do here, what are our operations to change this to a 0 and this to a 0? I can't hear you. So you pivot, did you say pivot the 1?
Yeah.
Remember, I have a Bluetooth in my ear, and the people in the hallway or in the other room are loud, so I'm trying to decipher. So you pivot that 1. Then what are your operations to make the -3 a 0 and the 8 a 0?
Row 1 plus row 3, row 3, row 2 minus 8, row 3.
What was your last one again?
Row 2 minus 8, row 3.
Yes. Very good. Very good. So you have row 1 plus 3, row 3 to get a new row 1. So that's going to give us 5, 0, 0, and then what?
Oh,
500. 500. And then row 2, we're doing row 2 minus 8 row 3 to get a new row 2. So that's going to be 0.
5,
Mm-hmm.
0,
And
500.
500. Good. And then the last row doesn't change. So we have 0, 0, 1, 50. And now what can you do to row 1 and row 2? Yes. So now we do 1/5 times row 1 to get a new row 1. And we do 1/5 times row 2 to get a new row 2. So that's going to give us 1, 0, 0, 100, 0, 1, 0, 100, 0, 0, 1, 50. So this means you purchased 100 shares of WSR, 100 shares of HCC, and 50 shares of SNDK. And it makes sense because they all add up to 250, which is the total we had. Okay? All right, now let's finish going through let's go through our last example. So we're going to talk about traffic flow. All right, so the traffic through downtown East Podunk flows through the one-way system shown below, this system here. Traffic counters find that 300 vehicles enter town from the west each hour, and 300 leave town toward the east each hour. Also, 100 cars travel down Canal Street each hour, so they're traveling down. Notice that here is the flow, here is the flow. So we're going to write down the general solution of the associated system of linear equations, and we're going to answer the question, is it possible to determine the number of vehicles on each street per hour? So we need to come up with these equations, so let's do that. So let's figure out what our unknowns are. Okay, so notice that here you have intersection A. Let's label all of this. So let's label April Street as X, Division Street as Y, Canal Street
or Broadway. Broadway is Z. And then embankment, we're going to call W. Okay? Now, at intersection A, at intersection A, we know that traffic in is the same thing as traffic out. Okay? So that means that going in, we have 300 cars, and 300 cars have to go out. They can choose to go on April Street or Broadway, but going in has to be equal to going out. So that means 300 is going to be X plus Z. Okay? So we have 300 is equal to X plus Z. That's a Z. Let me make it a little better. Okay? Or we can write X plus Z equals 300 because we're used to having our variables on the left. So you choose whichever one makes you happy. Okay? So now let's talk about what happens at intersection B. So at intersection B, same thing happens as far as traffic. And what is intersection B? This is intersection B here. Okay? So at intersection B, traffic in is the same thing as traffic out. So we have Y plus W is going to be equal to 300. So we have Y plus W is equal to 300 because traffic in is traffic out. At intersection C, we have traffic in is traffic out. So notice that here, traffic is going in, but then you have traffic going out, these both two ways. Okay, so traffic in is the same thing as traffic out. So that means that X is equal to 100 plus Y, right? 100 from Canal Street, and then division you have is represented by Y. Okay, which means if we put our variables on the left, that means X minus Y is equal to 100. At intersection D, again, traffic in is the same thing as traffic out. So notice that you have Z here and going in, and you have Canal Street, which was 100. So Z going in plus 100 is going to be equal to W. So we have 100 plus Z is equal to W, or we can write negative Z plus W is equal to 100. So we have 4 equations. Remember, that was a 0 there, make it better. So we have these as our 4 equations. Now what we're going to do, we're going to put them in an augmented matrix and we're going to solve. Okay, let's do it. So let me use red to be consistent. Okay, so here we go. We have our first equation gives us 1, 0, 1, 0, 300. Then we have 0, 1, 0, 1, 300. Then we have 1, negative 1, 0, 0, 100. And then we have 0, 0, negative 1, 1, 100. Okay, so remember that our column 1 represents X. We have Y, Z, and W. Okay, so there we go. Now let's row reduce. So we have a 1 here. We want zeros here in the remaining column entries on column 1. We already have 2, so we just want to create a 0 here. So what we're going to do, our operation is going to be row 3 minus row 1 to get a new row 3. So that means the other rows stay the same. So we have 1, 0, 1, 0, 300. We have 0, 1, 0, 1, 300. And then this is where we're changing row 3. So we do 1 minus 1, we get 0. Then we have negative 1 minus 0 gives us negative 1. Then we have 0 minus 1 gives us negative 1. And then we have 0 minus 0 is 0, no fun. And then 100 minus 300 is negative 200. All right, perfect. Last row does not change. Okay, so far so good. Now, just to remind you, we use this 1 as our pivot. Now, we created zeros off of the leading 1 in column 1. Now, this 1 is going to become our pivot, and we're going to make this negative 1 in row 3, column 2, a 0. So, we're just going to add the 2 rows to create a 0. So, we're going to change row 3. So, the operation here, we're going to add row 3 plus row 2 to get a new row 3. Remember, we're starting out with the row we're changing. So this is going to become 1, 0, 1, 0, 300. Doesn't change. Row 2 doesn't change either. So we have 0, 1, 0, 1, 300. Row 3 is going to change. So we have 0 plus 0, 0. Then we have negative 1 plus 1 gives us 0. Then we have negative 1 plus 0 gives us negative 1. Then we have 0 plus 1, that'll give us 1. Then we'll have negative 200 plus 300, that gives us 100. And then the last row does not change. Okay? Perfect. Now we move on, and now our pivot becomes this negative 1 here. So now we want to make this 1 a 0 and this negative 1 a 0. And to make that happen, these are the following operations we need to do. We need to say add row 1 plus row 3 to get a new row 1. Then we need to take row 4, subtract row 3 from it to get a new row 4. And then row 1 is going to change. We're adding row 1 and row 3, so 1 plus 0 is 1. We have 0 plus 0 is 0. Then we have 1 plus negative 1, that gives us 0. Then we have 300. We're doing row 3 plus row 2. 100 plus 300 gives us, no, I'm sorry. We have 1 plus 0. Let's not skip anything. We get 1. Don't rush it. And then we have 100 plus 300 gives us 400. Okay? So we got it without rushing. Now, row 2 is not changing. We're using row 2 doesn't need to change because we have a 0 where we want it. So 0, 1, 0, 1, 300. Now row 3 isn't changing because that's where our pivot is coming from. So we write that down. And then row 4 is going to change. So we have 0, 0. That's going to stay the same. So 0, 0. Then we have row 4 minus row 3. So negative 1 minus a negative 1 means we're adding them. So we get 0 as desired. Then we have 1 minus 1. Well, that gives us 0 as well. And here we have 100 minus 100. Well, that's 0 too. So we have a row of zeros. Well, that's interesting. That means we must have something that's arbitrary in the mix. Okay? Now we're going to look at row 3. We look at row 3 and we say, okay, this is a negative, so let's just multiply everything in this row by -1. You may be thinking, hey, well, we didn't make these ones a 0. Well, we can't really using any other number as our pivot because this row is all zeros. That's why we stop here and then realize that we can multiply row 3 by negative, and then we can write out our solution. Okay? So we are going to multiply row 3 by -1 to get a new row 3. Rows 1 and 2 will remain the same. And then row 3, we're going to have the opposite of everything we have. So 1, -1, -100. And then we're going to have this row of zeros here. Now, translating this information, remember what our columns represent. This column is X, this is Y, Z, and W, right? And so what this row of zeros means, it means that Z is going to be arbitrary because we don't have a leading 1 here. So this translates as, we'll write down the equations based on the row. This row says X plus W equals 400. So we have X plus W equals 400. We then have, the second row tells us Y plus W is equal to 300. So Y plus W is equal to 300. Then the third row tells us that Z minus W is equal to -100. And then the fourth row tells us that W is arbitrary. Now notice, since W is arbitrary, we are able to solve these 3 equations for X, Y, and Z to put them in terms of W. So our general solution will be in terms of W. So we can say X is equal to 400 minus W. Y is equal to 300 minus W. And Z is equal to I'll make that better, -100 plus W, and W is again arbitrary. Okay, so we'll write our solution as 400 minus W, 300 minus W, -100 plus W, and W. Okay, so this means there are infinitely many solutions. Okay, now what does that really mean? We still have to answer the question, which said, is it possible to determine the number of vehicles on each street per hour? Since there are infinitely many solutions, it is not possible to determine the number of vehicles on each street per hour. And remember, we cannot do that because there are infinitely many solutions. Okay? There you go. Now we have a couple more parts to this problem, and they're on the next page, so let's go ahead and do that. Okay? On which street could you put another traffic counter in order to determine the flow completely? Okay, so it says, on which street could you put another traffic counter in order to determine the flow completely? If you look back at your diagram, you can measure the traffic flow on any of April, Broadway, Division, or Embankment. Okay, so that will determine the answer. Okay, so the answer here is measuring the traffic flow on any of April, Broadway, B-R-O-A-D, we can spell. Division or embankment. Will determine the answer. Okay? And then in part C, it says, what's the minimum traffic flow along April Street? Or it says, what is the minimum traffic flow along April Street consistent with the information given? So from the general solution, which was the last thing we boxed on the previous page, in part A, the traffic flow along April Street is given by X equals 400 minus W. Now, we know that W has to be between 100 and 300, okay? It has to be between 100 and 300 because those are the cars that's flowing, okay? It's the traffic flow. So since the largest possible value of W is 300, the smallest value of X will be 400, or is 400 minus 300, which equals 100 vehicles per hour, which answers our question. Okay, now there's one last thing to note. When you're working on your homework from this section, you can actually go and check your solutions to reducing matrices by going to www.waynermath.com. You can click online utilities, that tab, and click pivot and Gauss Jordan tool. Enter your matrix entries and then press reduce completely. This is just a method where you can check them. All right, that's it. Applications of systems of linear equations.